In this lesson, we will answer the following essential question. When two tangents are drawn to a circle, how do you find the measure of the angle formed at their intersection? As we'll discover in class, given any point outside of a circle, we can draw two tangent lines to the circle. The two tangent lines form what's called a circumscribed angle. A circumscribed angle is an angle formed by two tangents to a circle. In the figure, notice that ray QP and ray QR are tangents to the circle C. Therefore, we call angle PQR a circumscribed angle. A circumscribed angle of a circle and its associated central angle are supplementary. So, notice by definition, angle Q is a circumscribed angle, whereas angle C, if I draw in the radii, CP, and the radius CR, angle C, therefore, we refer to as a central angle. So what this theorem says is that the circumscribed angle and angle C are supplementary, which means that they add up to 180 degrees. We're going to prove this now. So given that PQR is a circumscribed angle, we're going to show that angle PQR and angle PCR are supplementary. Since PQR is a circumscribed angle, I know that QP and QR are tangents. That's the definition of a circumscribed angle. Therefore, angle QPC and QRC are right angles by the tangent radius theorem. If you remember, we had a theorem in class that said that if I have a tangent line drawn to a circle, and I have the radius of the circle drawn to the point of tangency, then essentially what I've created is a right angle. So that's what this statement says. Angle QPC is a right angle by what's called the tangent radius theorem. So I know this is a right angle here. What this means is, if I draw in these radii again, you will see that basically what I've created is a quadrilateral. Okay? I've created a quadrilateral, and I know that all of the angles inside of a quadrilateral add up to 360 degrees by what's called the Quadrilateral Sum Theorem. So all these angles add up to 360. So if I substitute the measure of angle QPC and QRC into this equation, I get the following result. The only thing I did is I just substituted the values of the measures of those angles into my equation. And if I simplify, I get the following result. And if I simplify further by subtracting 180 from both sides, I get the following result, which basically says that the measure of angle PQR and the measure of angle PCR add up to 180 degrees. Therefore, by definition, angles PQR and angle PCR are supplementary. So that's the formal way of looking at this fact, but another informal way would be to look at it in the following way. So let me draw in these radii to the points of tangency here. Okay. So of course I've created a quadrilateral. I've created a quadrilateral, and I know by the tangent radius theorem that since these are tangents, I've basically created two 90 degrees here, two 90-degree angles here. But since I have this quadrilateral, I do know that all of the angles, when they add up, when you add them up, they add up to 360 degrees. But if I have 90 already here and 90 here, between these two angles I have 180 degrees. Which means that between these two angles I must have 180 degrees. Which, from that, we can conclude that this angle Q and this angle C are supplementary, which is exactly what we were trying to prove.